Hello friends, welcome back to Pharma-info with Shubhashish. Today's topic is clearly visible, I think. Synthesis of Tolbutamide, right? So what is Tolbutamide, right? This is the drug which can be given to the patient who is suffering from type 2 diabetes. This can also be called as NIDDM, non-insulin dependent diabetes mellitus, right? So this is the drug of choice in the treatment of type 2 diabetes. That can also be called as NIDDM, that is non-insulin dependent diabetes mellitus, right? So this is about the pharmacological aspect, right? Because the topic is synthesis of tolbutamide, so no need to go in deep to the pharmacological aspects and all, right? So now straightway we'll just move to the chemical category in which tolbutamide belongs, right? So it belongs to the chemical category of sulfonylureas, right? So it belongs to the chemical category of sulfonylureas. Sulfonylureas, we can say that sulfonylureas are found to be one of the primary classes, right, under the oral hypoglycemic or the drugs which are meant for treating diabetes mellitus of type 2, right? So now let's move on to move on to some more detail, right, about this tolbutamide and all. So what is sulfonylureas? So sulfonylureas, if we just try to chemically figure it out, it looks like this. This is the basic feature, the raw feature of sulfonylureas, right? Now definitely some additional things need to be added just to make the structure of tolbutamide, right? So what are the additional things that is there in tolbutamide, right? So it is the chemical class from which you came to know that this is it possesses or it contains this framework, right? Now in addition to this framework, what are the other things that is also there in tolbutamide? So that can be what we can say, that can be fetched from the name itself, right? So name suggests that tol for toluene. So the additional things, one of the additional things is toluene, the other one is butyl, that is C4H9 unit, right? Now let us just assemble them, right? Let us just bring them all together, right? And let's see that how the structure looks, right? Chalo. So in that very process, let us just see that how the entire structure looks. So we have taken few things from the chemical name, we have observed few things from the name, right? Now as a whole, let us see that how it looks. So toluene is something like this. So this is your toluene, right? To that toluene, the sulfonylurea is attached. So like this, I'll just make it like this, right? So here we have, and what is left in the process, that is nothing but C4H9, right? That has to be placed here, right? Because it is associated with the amide, that is carboxamide, right? Though we are not considering this as a carboxamide because it's a part of the urea, right? It's part of urea, right? So this is how the structure looks like. Now let us move to the Ipc naming and all, how it goes actually. So Ipc naming is urea. Basically it is sulfonylureas, so the parent is nothing but sulfonylureas. Sulfonylurea, right? Sulfonylurea. So urea, we know the numbering of urea. This is something 1, this is 2, this one is 3. So position 1 holding a substituent, position 3 holding a substituent, right? Position 3 holding the main substituent as sulfonyl. To that sulfonyl, this is the secondary substituent which is attached, right? So now how it goes actually. So sulfonylurea, so this is found to be the parent, right? Now let us see that what are the substituents which need to be mentioned here. So now position 1, so likewise we'll just write 1 butyl, right? Then followed by 3. 3 is holding what? The sulfonyl as the primary substituent, okay? And the secondary one is nothing but the same 3 is holding what? The same 3 is holding 4-methyl phenyl, right? Close the bracket. So this is found to be the third nitrogen holding sulfonyl. To that sulfonyl, the 4-methyl phenyl or para-tolbutyl is attached. So likewise, as a whole, we can say this is how the Ipc naming goes. 1 butyl, 3, 4-methyl phenyl. This is the 4-methyl phenyl. We are done with the entire thing, right? What is left in the process? Sulfonylurea. So this is sulfonyl and this one is urea. That's all. So this is how the Ipc name stands. Now let us move on to the synthetic process. Okay, the synthetic scheme, right? The synthetic scheme with which we can develop the the compound that is tolbutamide, right? Chalo. So now in that very process we have with us a structure, we have with us the compound which we are going to make, right? So now from the structure, what are the informations that can be fetched, right? This can give us an idea about the starting materials which are involved. This can give us an idea about the various reagents which are involved in different steps, okay, in the process of making or during the process of making tolbutamide, right? So in that way, let us just see that what are the different fragments that can be shorted out from this particular entire structure, right? So in that very process, let us do one thing. Let us just split the entire structure into several fragments. What are the several possible fragments which can be further manipulated to develop the reagents which are likely to be involved in making tolbutamide, right? So this is found to be one of the portion, that is fragment 1, right? This is another portion which can be further taken out from the entire structure, sulfonyl, that is fragment 2. This is the amino, that is fragment 3. This one is the the carbonyl, that is, we can also incorporate carbonyl by means of introducing some other reagent, right? So that is why we have considered this as another fragment, and we are left with the final fragment, that is nothing but the butyl amino, right? Now let us see that how they can be shaped, right? How they can be given a certain shape through which we can and so that we can consider them for the purpose of making tolbutamide, right? Sure. So now fragment 1. So nothing, not much thing to add here, right? Because tolbene, F1 is tolbene, this is tolbene substituent, right? So basically the fragment 1 can be considered as tolbene. So thus we got the starting material, one of the starting materials, that is tolbene. Now coming to this sulfonyl, right? Sulfonyl. How sulfonyl group can be inserted? What are the possible reagents with which we can extract sulfonyl, right? One of the key reagent is found to be chlorsulfonic acid, right? So hence F2 can be chlorsulfonic acid. How it looks actually? So it looks like this, chlorsulfonic acid, right? ClSO3H, chlorsulfonic acid. Thus we got the sulfonyl, right? What about the amino? So amino, if we just try to manipulate it, this will give rise to ammonia, right? So fragment 3 may be ammonia, right? Now coming to this carbonyl, right? The carbonyl should come, we can incorporate carbonyl if we just consider the reagent called ethyl chloroformate, right? So how it looks actually? So what will be the possible shape of this particular fragment while modifying it? So this is ethyl chloroformate, So we'll just write here C2H5, ethyl chloroformate. So ethyl is found to be the alkyl portion, then formate is like this, and at this position we have to put one chloro. Thus we got what? Ethyl chloroformate, right? Chalo. Now it is the hydrogen that has to be replaced with chlorine so that we can get ethyl chloroformate. So this is found to be the final shape of this F4, right? Or probable shape of this F4, right? In the form of a reagent, right? Chalo. And finally F5, this should be a butyl amino. Butyl, not amino, right? This is acting as a substituent, right? So butyl amine is found to be the reagent with which we can just complete the show. We can just complete the event, right? So these are the various informations that we got while dissecting the compounds in possible fragments, right? So we have dissected the compounds in so many parts, right? And while dealing with each and every part, we just got to know that what are the possible reagents that are likely to be involved in making tolbutamide, right? Chalo. So this is all about your what we can say. This is all about the collection of the starting materials or collection of the various reagents, right, which are involved in making tolbutamide. Now we'll just place them in a proper order, right? So initially, what can be done? So this is the tolbutamide. So we have seen that the fragment 1 is found to be toluene. So likewise, we'll just write here toluene. Toluene has to react with chlorsulfonic acid, right? So I'll just orient chlorsulfonic acid in such a way so that it can leave the sulfonyl, okay? It can leave the sulfonyl and the sulfonyl should remain with this, okay? So it should be fixed to this particular portion. So chlorsulfonic acid, so this is your chlorsulfonic acid. Sulfonic acid. While reacting them all together, there is a possibility that you can get what? This remains same, hydrogen and hydroxyl. Both will leave in the form of H2O, right? Chalo. So here एक तो हाइड्रोजन था यहाँ पे. So now what happened here? What happened here? H2O will go off, right? Leaving behind what? Sulfonyl chloride. So thus we got what? Intermediate 1. INT1. We'll just consider it as INT1, intermediate 1. That is nothing but what? This is basically 4-methyl phenyl sulfonyl chloride, right? Okay. What about intermediate 1? If we just try to, react. Now what next? SO2. उसके बाद क्या लाना है? Ammonia को लाना है. Now do one thing. Bring ammonia, right? Bring ammonia. What this ammonia will do? Ammonia will just put, give one of its hydrogen. This hydrogen will just react with this chloro and thus chlorine and hydrogen has to be eliminated, right? Both have to be eliminated, right? And leaving behind what? SO2 NH2, right? So now thus we got what? The intermediate 2. That is your the same sulfonyl chloride has been converted to sulfonamide, right? So this is your intermediate 2. Intermediate 2. That is sulfonamide, 4-methyl phenyl sulfonamide, right? Okay. Now what next? इसके बाद क्या लाना है हमको? CONH. That means we cannot bring CONH as such because according to our design, according to our plan, according to our collection of reagents, right? We have seen that as such as a in a single step we cannot introduce CONH, rather one after another. So first introduce CO, just connect the CO with to this nitrogen and then we'll just add butyl amine so that butyl amino group can be attached, right? So now the intermediate 2 has to react with what? As I said, ethyl chloroformate. So how it looks actually? Ethyl chloroformate. So now we'll just write it like this: Cl, then CO, then O, then C2H5. Ethyl chloroformate. So what this ethyl chloroformate will do? This is the chlorine, right? This is the chlorine minus I effect. It will leave, right? And it will take one hydrogen from this area, right? So that there is a formation of intermediate 3. How it looks actually? So H3C, then SO2, then NH, then CO, then OC2H5. And just remember one thing: ethyl chloroformate cannot be introduced alone, right? In presence of pyridine, this reaction, this step has to be carried out, right? Pyridine is acting as a base catalyst right here. So thus we got what? Carbamate, sulfonyl carbamate, because this is the fashion of carbamate. Ethyl carbamate, right? So this is carbamate, and to this nitrogen what is attached? 4-methyl phenyl sulfonyl, right? Chalo. So this is NHCO, that is nothing but carbamate, right? So thus we got what? Intermediate 3. Intermediate 3. So we are almost done, right? So this is the toluene chlorsulfonic acid will produce intermediate 1. To that intermediate 1 we have just introduced ammonia, right? This ammonia reacted with this so that there is a formation of sulfonamide. The same sulfonamide has to react with ethyl chloroformate in presence of pyridine, right? There is a formation of carbamate, right? And now what is left in the process? The intermediate 3 has to react with what? Butyl amine, that is H9C4 NH2, right? So what will happen? C2H5O minus is a good leaving group, right? This will leave and this will take one hydrogen from this type amino, right? And thus leaving and the portion which is left that is that should attach to this carbonyl, right? Thus we got what? Not the intermediate, rather the final compound. The final compound, that is sulfonyl, then NH, then CO, then the butylamine, right? So NH, then C4H9. So thus we got what? Our desired compound, that is tolbutamide. So with that we are done with the making of what? Tolbutamide. This is one of the easiest process, okay, with which tolbutamide can be built, right? So hope you have understood, right? So let us just brush it up once more. So initially toluene, right, it will react with chlorsulfonic acid. There is a formation of sulfonyl chloride, right? And the thing is that, okay, we have started our process, started the the making of tolbutamide, just simply focusing on the structure which we need to build, the compound which you need to build. We have just dissected it in so many parts. We have dealt with each and every part, right? And we have just manipulated them so that we can give each and every one a shape, right, which can be considered for the reaction, for the synthesis, right? And thus we have collected the possible reagents, right? And with this and we have just introduced them one after another, and that too in an orderly manner. and so that we can get finally tolbutamide. So once we get the intermediate one, that has to be reacted with ammonia, right? So that we have got sulfonamide, and this sulfonamide has to be reacted with ethyl chloroformate in presence of a base, that is pyridine, right? So that there is a formation of carbamate, that is our intermediate 3, and finally we are left with what? Butyl amination, right? Alkyl amination. Alkyl amino group has to be attached, right? How this can be attached? With the help of, in presence of butyl amine. It is the butyl amine, one hydrogen, C2H5O minus. Okay, both should leave in the form of C2H5OH, leaving behind what? Butyl amino. Thus we got what? 1, 2, 3, 1 butyl, 3, 4 methyl phenyl should be in the bracket, should be within bracket, right? Sulfonyl urea. That's all. So with that we are done with what? The making of tolbutamide. Hope you have understood the fact and file which is there, which has been kept in the making of tolbutamide, right? So if you like this, then if you think that yes, we can we can just press the like button, no problem at all, right? So stay tuned and let's see that what will be our next topic, right? Thank you very much. Thank you for your patience. Thank you.